Okay, the next topic it's module 4, Cauchy Integral Formula, lecture 3. I think this is lecture. Now, in this lecture, we will discuss Cauchy Integral Formula and KTU problems uh, by solving by using Cauchy Integral Formula, and further we will do some exercise questions. Okay, so we will discuss what is Cauchy integral formula first. Okay, Cauchy integral formula. Let f of z be analytic in a simply connected domain D. Okay, then for any point z naught in uh, in D, that means z naught is any point in the domain, and any simple closed path C in D that encloses z naught. Okay, that means if you have a domain, I am taking it's a complex plane D, and C be any simple closed path. Okay, so Z naught is a point inside the C. So this is a point Z naught inside C, simple closed path. Then integral over C f of Z divided by Z minus Z naught. So here the function, this function is not analytic at Z equal to Z naught. Okay, then the denominator becomes 0. So then this is equal to 2 pi I into f of z naught. So what is f of z? This. Okay. So f of z must be analytic. So the numerator part must be analytic, and denominator you must have z minus z naught. Then we can use Cauchy integral formula. Okay. For now I will do few examples. So now here, so consider an example. You have to calculate integral over c e raised to z by z minus 2 dz, and for any contour enclosing z not equal to 2. So suppose our contour means simple closed curve enclosing 2. Suppose this is our C. Then by Cauchy integral formula, this numerator part is e raised to z. So f of z equal to e raised to z is analytic. Okay. Now what is z naught here? Z naught is 2, and 2 is inside the contour. Then we can use Cauchy integral formula. What is Cauchy integral formula? Integral over c f of z divided by z minus z naught dz is equal to 2 pi I into f of z naught. So here, which implies integral over c f of z is e raised to z, z minus 2 dz is equal to 2 pi I into f of z naught. Z naught is 2. This is equal to 2 pi I into f of z is e raised to z. So e raised to 2. So this must be the answer. Now if you take any contour outside C, that means that doesn't encloses 2, then what will happen? This entire function will be analytic, right, inside this contour. Okay, then by Cauchy integral theorem this must be equal to 0. So the thing we have to check is whether this 2 is inside the contour or outside the contour. Inside the contour or outside. If it is outside, then by Cauchy integral theorem that must be equal to 0. If it is inside, then we have to use Cauchy integral formula. Now if you we will do the next problem. So this is integral z cube minus 6 divided by 2z minus I. So now first we have to make in this form. So here okay, this integral over C. So how to make this? I am dividing both numerator and denominator by 2. So this is z cube minus 6 by 2 divided by z minus I by 2. Okay. Yes. Now, now, now if you take any contour, here what is the point z naught? Z naught is I by 2. Now if you take any contour, this is I by 2. This is simple closed curve C. So if our C contains I by 2, then what you can do? We will use Cauchy integral formula. 2 pi I into f of z is this numerator part. So f of I by 2. If you take any other contour, this is C. Here I by 2 is outside, therefore this must be equal to 0. For this C, so I am taking C2. This C2, then if you integrate this C2, then the answer must be 0. So the thing we have to check is, you have to find the Z naught and you have to check whether Z naught is inside the contour C or not. So now we will do first problem. This is KTU 2018, April 2018 problem. Okay, so here using Cauchy integral formula, in evaluate integral over C z square divided by z cube minus z square minus z plus 1 dz, where C is taken counterclockwise around the circle mod z plus 1 is equal to 3 by 2. So solution, first one, we have to integrate integral over C z square divided by z cube minus z square minus z plus 1 dz. Okay. And C, first our contour C is mod z plus 1 is equal to 3 by 2. So now first we will draw what is our contour C or path C. So this is mod z plus 1 equal to 3 by 2 means mod z minus minus 1. Center is minus 1 is equal to 3 by 2 and radius is 3 by 2. So this is a circle with a center minus 1 and radius 3 by 2. So this, if this is a circle, so this is our. Now we will find what are the, when this integrand is not analytic, when z cube minus z square minus z plus 1 equal to 0. So you have to find out the roots. So if you have a calculator, you can easily find a root. Otherwise, I am just using Google. Okay. In examination, you can find calculator. You can find root by using calculator. Equation. And otherwise, you can use cubic equation. So I'm using this. Okay. So coefficient. Okay. So what are the? This is a cubic equation. Okay. Z cube coefficient is 1 minus 1 minus 1 1. So I will use 1 minus 1 minus 1 1. Okay. So I am calculating the roots. So I will get root is 1 minus 1 1. So the roots are, so roots are z equal to 1, 1, minus 1. So this can be written as integral over c z square divided by z minus 1 all square into z plus 1 dz. Okay. So the roots of this equation, this polynomial is 1, 1, minus 1. So you can write it as z minus 1 all square into z plus 1 dz. Now, now, so here, what are the points when is denominator is equal to 0? When z equal to 1 or minus 1. Okay. So I am checking where is minus 1. Minus 1 is inside C and 1 is outside C. So there are two roots. Denominator has two roots. One is minus 1 and other one is 1. So minus 1 is inside and 1 is outside. So this you can written as integral over C. So 1 is outside, therefore f of z is analytic at 1. So this can be written as I am taking z minus 1 all square on the numerator divided by z plus 1. Why? Because minus 1 is outside, therefore this is analytic. Therefore you can written as this. Okay. Now here f of z equal to numerator part is z square divided by z minus 1 all square. Okay. Now by Cauchy integral formula, you can write this is equal to 2 pi I into f of, what is the point, f of minus 1. So this is equal to 2 pi I into f of minus 1. So f of minus 1 is minus 1 square divided by minus 1 minus 1 all square is equal to 1 by 2 square minus 2 all square 1 by 4. So this is 1 by 4. Therefore answer is pi I by 2. So here what we done, we check where at what points the denominator is 0. So we find the roots, therefore at points where minus 1 and 1 the denominator is 0. So we check, we draw the contour and we find that minus 1 is inside the circle and 1 is outside the circle. If you draw some circle like this, then if C is like this, then you cannot use Cauchy integral formula because it has a power 2. So we cannot use the formula. So but here our circle is this. Okay. Now we will do the second problem. Second problem. Our C is a second problem. Our C is mod. Okay, this is our C. Mod z minus 1 minus I is equal to pi by 2. Mod z minus 1 minus I equal to pi by 2. So implies this can be written as mod z minus of 1 plus I is equal to pi by 2. So here the center is 1 plus I and radius is pi by 2. So I am taking, I will draw the, so one of the important thing is you have to draw the curve or C first. Okay. So here center is 1, 1, 1, 1 and radius is pi by 2. So pi by 2 is 3.14 divided by 2, some radius around 1.6 or something. So okay, this is our C. Okay, 1 plus I. This is our C. Now we have to integrate integral over c z square divided by z minus 1 all square into z plus 1 dz. Now the points at which f of z is not analytic is z equal to 1 minus 1. Now we have to check whether 1 or minus 1 is inside the circle. So for that what we will do is, instead of z I will put first we will check z equal to 1. If I put z equal to 1 here, 1 minus 1 minus I. So distance from 1 to 1 minus I is equal to I. 1 to 1 minus mod I is equal to uh, I is equal to, so I which is equal to 1. So this is less than pi by 2, but so 1 is inside the circle. But what is the problem? In this problem, we cannot use Cauchy integral formula. And if you find minus 1, if I put minus 1, z equal to minus 1, minus 1, 1 minus I is equal to minus 2 minus I. Mod minus 2 minus I is root 2 square plus 1, which is equal to root 5, which is greater than 1 by 2. So minus 1 is outside and 1 is inside. But so we can write this as z square divided by z plus 1, because minus 1 is outside the circle and 1 is inside the circle, all divided by z minus 1 all square dz. But this is of the form integral over c. So if you take this is f of z, so this is of the form f of z divided by z minus 1 all square dz. But we cannot use Cauchy integral formula. So next class we will study how to do these type of problems. Okay. So here, because z minus 1 all square is there, so we cannot use Cauchy integral formula, because in Cauchy integral formula you must have the integral of this type, f of z divided by z minus z0. Okay. So next we will do next problem. Okay. So the second problem, using Cauchy integral formula, evaluate integral over c z square plus 1 divided by z square minus 1 dz, where c is taken counterclockwise around the circle mod z plus 1 is equal to 1, and second one mod z minus 1 equal to 1. So solution, so I'm taking first problem, first contour. So we have to integrate integral over c z square plus 1 divided by z square minus 1 dz. So this can be written as integral over c in z square plus 1 divided by z square minus 1 is z plus 1 into z minus 1 dz. Okay. Now our first I will draw the circle. So what is our c for first case, for first problem? C is this, mod c is mod z minus plus 1 equal to 1. So here the center is minus 1 and radius is 1. So this is our, okay. So what are the points? The denominator is 0 when z equal to minus 1 and 1. So z equal to minus 1 is inside, z equal to 1 is outside. So z equal to minus 1 is inside, z equal to 1 is outside. So this can be written as z equal to 1 is outside. So you can write z square plus 1 divided by z minus 1. This you can take in numerator because this is analytic, and z plus 1 dz. Okay. So here f of z is analytic here, therefore you can take f of z is z square plus 1 divided by z minus 1. That means this is analytic in C, because the only point where f is not analytic is 1, that is outside C. So this is analytic. Therefore integral over C z square plus 1 divided by z minus 1 all divided by z plus 1 dz is equal to 2 pi I into f of, here z naught is minus 1. So this is 2 pi I into f of minus 1 is, f of minus 1 is, you can write minus 1 square plus 1 divided by minus 1 minus 1. So instead of z I will put minus. So this is 2 by minus 2, which is equal to minus 1 minus 1. So this into minus 1. So this is minus 2 pi I is the answer. Now we will check what is next contour. Our second contour, the second contour is mod z minus 1 is equal to 1. This is KTU December 2019 question. So our second contour is this. So first step is we have to draw the curve path. So this is a circle with center 1 and radius 1. So this is 1 and radius 1. So this is our C, and we have to integrate integral over C z square plus 1 by z square minus 1 dz. This you can written as integral over C z square plus 1 divided by z minus 1 into z plus 1 dz. Okay. Now here the points at which denominator is 0 is 1 and minus 1. So 1 is inside and minus 1 is outside. So this you can written as integral over C z square plus 1. Minus 1 is outside, so you can take this on the numerator, z and z minus 1 dz. So this is analytic, therefore f of z is equal to z square plus 1 divided by z plus 1. Now by Cauchy integral formula, integral over C z square plus 1 divided by z plus 1 all divided by z minus 1 dz is equal to 2 pi I into f of 1. So this is equal to 2 pi I into, so this is f of z, so f of 1 is 1 square plus 1 divided by 1 plus 1. This is 2 by 2, which is 1 into 1. So this is the answer, 2 pi I. Okay, so that is the answer. Okay, now I will just discuss what the problems, textbook problem. Okay, so here also we want to find this integral. So here integral over dz divided by z square plus 4 dz, integral over c dz divided z square plus 4 you can written as z plus 2i into z minus 2i. And here c is given as an ellipse, y minus 2 all square is equal to 4. So some ellipse is like this, and we have to check whether 2i and minus 2i is inside the ellipse or not. So how to check that? So what we will, if z equal to 2i, so here this is of this form. So here in z equal to 2i, x equal to 0 and y equal to 2. That is z equal to x plus iy form, therefore x equal to 0 and y equal to 2. Now we have to insert this here and check whether this is less than 4. If it is less than 4, then inside the contour, and if it is greater than 4, outside the contour. So substitute z equal to 2i. Z equal to 2i means x equal to 0 and y equal to 2. So 4 into x0 plus y equal to 2 minus 2 all square is equal to 4, is 2 minus 2. So that is equal to 0. 0 is always less than 4. So this point inside the contour, 2i is inside the. Now you check whether z equal to minus 2i is inside. Minus 2i means x equal to 0, y equal to 2i, minus 2, y equal to minus 2. So now you substitute here 4 into 0 square plus y is minus 2. I am substituting here minus 2 all square. So this is equal to 0 plus minus 4 all square, which is equal to 16, which is greater than 4. Therefore minus 2y is outside the contour. So you can written as minus 2y is outside the contour, 2y is inside the contour. This is outside. So you can written as z square, okay, dz by z square plus 4 is equal to integral over c dz. Okay, so 1 by z minus z plus 2y on the top, because minus 2y is outside, z minus 2. Then you can use Cauchy integral formula. So similarly, I will give an hint here. In this problem, we have to integrate integral over c z divided by z square plus 4z plus 3 dz. This you can written as integral over z z plus 1 into z plus 3. Now if here your contour is what is our contour is a circle with center minus 1, center minus 1 and radius 2. So I will do center minus 1 and radius 2. So radius 2. So 3. So what are the points of singularity? Or minus 1 and minus 3. So 1 minus 1 is here, 3 is here. So both are inside the contour. So what we will do is here you can split it into 2. Z plus 1 into z plus 3. This you can find by partial fraction plus b by z plus 3. Now if you find a and b, then you can split this integral into 2. Okay, integral into 2 and use Cauchy integral formula. So this is the idea. If both are inside and there is no power, then you just find the partial fraction and split the integral and find the form find the answer. Okay.